trying to use these technologies in novel ways in order to make things better on the retail side. And then we're even doing things like the Alexa and Echo devices, trying to have new ways of interacting with computers and trying to push the boundaries there as well. And all of these things are driven off of an understanding of machine learning and the whole process of collecting data, creating these models, and so on. And not only have we been able to do it, on AWS, we have thousands of customers that have been able to create these new experiences. It's everything from the Netflixes of the world who are creating new streaming experiences. There's companies like Digital Globe who have mapping experiences of various kinds, and they're able to do things at a scale that would previously not have been possible if you were not using machine learning technologies. So if you think of it in this context, what is our mission in AWS? Our mission is to put machine learning in the hands of every developer and every data scientist so that everyone is capable of creating these new things and making new experiences for customers and being able to do new things. Machine learning allows you to do things at scale that you previously weren't able to do before. So what is the thing that we're building? It's not just a single service. I'm here to talk about SageMaker, but there's a broader context as we look at all of these services in AWS. Essentially, what we're building on is we're building this stack. And the stack, if we when I usually talk about it, I start at the top of the stack. And the top of the stack, the reason I start there is because in some ways, that's the easy button for machine learning. It's how do you leverage Amazon's expertise, AWS expertise, and AWS data in order to provide these new experiences in your apps to your customers? And we call those application services because they're essentially the same as calling an API in your application. If you want to do things like identify the objects in an image, you can provide that image to the REST API of recognition, and you get a nice, well-structured response of what those are. Similarly, for transcribe, you provide audio, you get the text back, and so on. These are all machine learning services under the covers, but for the person who's consuming them, they don't even know it's machine learning because they're just simply calling the APIs. The next level, I'll call it, or next tier is platform services. And that's where Amazon SageMaker fits in. The way you want to think about how you would use that in your organizations is that these are the places where you have secret sauce. This is your key business activity. And you have data, you have potentially data scientists, maybe machine learning aware developers, really good developers who can use something like SageMaker. You're willing to invest in making that really great because that's important to your business. And that's where these platform services will help you. Amazon SageMaker is one of them, which helps with machine learning. Mechanical Turk is another that helps with actually assembling together the data set that you would use for machine learning, particularly for annotation or even data generation. And all of this is built on top of a set of frameworks, a set of open source frameworks that are available in the community. We participate in that community by interacting with partners like the Apache Foundation, interacting with partners like Facebook, and providing them with various kinds of input for how to make it better, and incorporating them into our products in order to make our products better. And the way we think about it isn't a one-size-fits-all solution. There isn't one framework that will fit them all. We've seen that something like on the order of 2/3 of data scientists use more than one framework. So you may say, hey, I want to use PyTorch for my language problems, or MXNet for recommendations, or TensorFlow for my images. As far as we're concerned, there are business drivers for using frameworks that aren't necessarily, we don't necessarily have full knowledge. You have the best knowledge for what will work for your business. So we're here to support those decisions no matter what framework you use. And all of this, of course, is built on top of a strong hardware platform. This includes the P3 instances in AWS that include the NVIDIA Volta 100 or V100 GPU. And there's actually a session about that hardware in AWS later today. Also, the C5 instances that are built on the Skylake processor, that both of which in combination provide a strong hardware platform that you can use for your machine learning. As machine learning is a pretty compute-intensive type of activity, and because of that, you need the best compute to work with. So let's start with a little bit of a review of the machine learning process, and then we can talk about the parts of the machine learning process that are accelerated using Amazon SageMaker. So the first part of the process is, of course, problem framing. And I've heard some people come to me and say, you know, how can I use machine learning to improve my business? And improve my business isn't really something that is a machine learning problem all by itself. You have to break it down into chunks that the machine can actually understand. So you can say, which of my customers do I think are likely to churn in the next 6 months? And that's a much more manageable problem for which you can collect data and you can actually use as part of this machine learning flow, as opposed to a broader problem like, how can machine learning improve my business? So you start with this framing, and then you go on to a process of data collection, integration with your existing systems, and usually there's a lot of preparation and cleaning. And it's things like if you have human collected data, if you collect the data from forms, if you're looking at something like US and United States, as a human being, you actually know that those two are synonymous. However, machine learning algorithms don't. So you actually go through this process of cleaning the data up, normalizing it, putting it in the form that is capable of being used for machine learning. And in fact, I've heard from data scientists that this is a substantial part of their activity, maybe even half of the time gets spent in this area. And this is also the area where Mechanical Turk plays in. The next part of it is you look at visualization and analysis to kind of understand what the data distribution looks like and see whether it's something that's suitable for machine learning. Sometimes you'll do things like feature engineering. And feature engineering is a pretty fancy term for you're trying to improve the data better by using human intuition. Let me give you an example of that. So supposing you were trying to use weather data in order to predict flight delays, and I know that's a common problem in O'Hare, especially in the wintertime. So if you look at temperature and humidity as two of the factors that go into predicting flight delay, and they may be factors that are relevant, by using temperature and humidity alone, you may get so far. But if you have an understanding that, hey, a combination of low temperature and high humidity leads to icing, you can actually create these features, these additional attributes that would lead into machine learning that is a combination of the two. And you say, well, this is an icing condition, and the other three I don't really care about. They're not icing, because regardless of temperature and humidity, only this combination actually makes sense. So the human intuition goes into generating this feature set. And then you have a set, once you have a feature set that you think is going to be good for machine learning, you put it into this model training parameter tuning process where you put it into a machine learning algorithm, you come up with a representative model that can potentially predict the output. In this case, it would be flight delay, yes or no, something like that. And then you evaluate it against your existing data set to say, is this actually a good model? Is it a good enough model that I can use it for my business activities? So then you say, are my business goals met? If they aren't met, then you can go back and you can add additional data. Or you can go in and you can say, well, maybe I need to take other combinations of features. Maybe there are ways that I can massage the features in order to actually get better results out of the same set of data. And then once you do that, you're going into deploying the model into a production environment where you can actually use it for predictions. And then the other part of it is, well, once it's in production, you have to monitor it, understand what the performance of this model is in production. Is it actually doing well? And then you collect data, and it's actually a very iterative process, because once you have it in production, you have the opportunity to correct more data. You have an opportunity for better understanding. You can say, oh, you know what? There are these cases that maybe I didn't think about before, and here's another set of data that I can collect. And you can go back into this data collection process. And the important thing to note here is that it's an iterative process. And the faster you go through this process, the better you get at machine learning. And prior to SageMaker launch, I heard from customers that this was taking them on the order of 6 to 18 months to get through this. And when I heard that, I was thinking, well, machine learning is an iterative process. I understand this as someone with a machine learning background. If you're taking 6 to 18 months, it's going to take forever for you to actually get better than your business logic. Some of you have business logic that has been in place for decades, and that business logic is highly tuned. And if you say, well, I actually want to try and use machine learning so that my business can be more agile and I can actually take more recent factors into account and use this machine learning model to do the same kinds of things, you need to iterate much faster. It needs to be on the order of weeks or even days, ideally. So that's why we actually look at this process and say this is something that needs acceleration. So the first part of it is about discovery, and you have analysts that are working to frame the business problem. The second part of it is about the data platform. And this is something where AWS provides a full set of services that you can use in order to analyze your data, store your data, understand the data, prepare it in various ways. And it's things like AWS Glue that helps you transform it and load it into Redshift. And you can actually do a lot with your data there. Once you actually do that, this is where SageMaker plays. So you set up your notebook environments to do data visualization and further analysis. You set up and manage these training clusters in order to do distributed training if your data sets are large enough that you're not able to do them on single machines. You do things like writing data connectors. And all of this is a pretty time-consuming process unless you have a platform to help you. So where should you be spending your time? I mean, the time that you really want to spend is in the activities that are really value-adding that you're having to think about. So you spend your time on thinking about what is it that I want to do, what is the data that I want to collect, what is the problem that I want to answer, and then what algorithm do I think will actually work for this? How do I tune the hyperparameters? And in large part, some of these things around training and tuning, the hardware will help you. So we have GPU-accelerated machines that will actually help you with this training and tuning process. We have the CPU acceleration in the deployment process, so you can do these things at scale. But essentially, what you want to do is you want to spend more of your time on setting up the machine learning problem and collecting the data that you need in order to answer that. So in order to help you do that, SageMaker provides a set of features in each of these stages. In the build stage, where you're thinking about building the model and thinking about collecting the data, you have a set of pre-built notebook examples that show you how to solve similar problems. So the customer churn idea that I mentioned, there's an example that says, here's how you use a specific algorithm in order to predict customer churn, and here's what it looks like with a standard data set. So in some ways, you're jump-started into solving that problem because you see that there's an example that you can use for that type of problem. It also has built-in high-performance algorithms for that. So the example in customer churn is it has gradient-boosted trees. One of the most popular gradient-boosted tree algorithms, XGBoost, in order to make it so that you can quickly train this model, and you don't need to spend a whole lot of time reinventing things that people have already invented, either in the open source community or within AWS. So we have this set of high-performance algorithms that we've written. We have some that are implemented from the best open source that's out there, implemented in a single platform that enables you to take advantage of all of them in one place. The next area is the actual training part and tuning that model so that it has the accuracy that you need in order to meet your business goals. And the tuning part of it has a mouthful of a name. It's usually called hyperparameter optimization or hyperparameter tuning. We call it automatic model tuning in SageMaker just because it's somewhat easier to understand. There are these model parameters or hyperparameters that you use in order to control the training process that enable you to get a better model out. And that's something that we have provided infrastructure within SageMaker to do that automatically in a very efficient way through essentially Bayesian optimization. So we pick areas within the hyperparameter space that we think will yield good results, and we optimize on those particular areas. And the result of it is really you get a better model at a lower cost. And that's our focus here. We want to make it easy so that you're only paying for the compute time that you're spending on it. You're not spending a whole time of development resources, inventing things that are already out there and already solved problems. And this way, as you go through these things, you're accelerating your entire machine learning process. And finally, the last thing is we have one-click deployment that lets you take these models and then put it behind a REST endpoint that can be incorporated into your applications in a fully managed environment that has auto-scaling built in, which means that not only can you use it for prototyping, it's not just an environment that you can use for prototyping, but you can actually put it into a production environment with several hundred transactions per second against this endpoint to several thousand. We actually, one of the customers I'll talk about later is Intuit. And we actually took on a production workload at Intuit through tax season. We took on production workloads for Amazon.com through Prime Day. So this is an environment that will actually let you scale all the way from I have this machine learning application in production all the way to it's some of the more critical, business critical loads that not only is business critical, but has extremely high transaction rates. So to go along with that, we've also done a bunch of things that businesses told us, our customers told us that we need in order to take on these business critical workloads, which is we need the controls in order to make sure that we're protecting the data adequately. Because if it's a business critical workload, you're actually putting in really important data into these things. So as a platform, we want to make sure that we're protecting them. So we have things like end-to-end encryption with KMS. We have compliance and audit capabilities. So we're integrated with CloudTrail that provides you with an audit log. We're eligible for HIPAA, PCI, as well as ISO. We have VPC, Virtual Private Cloud support, which means that the data that goes to SageMaker from your data stores doesn't traverse the public internet. And we're providing this set of capabilities in order to make sure that we're acting as good stewards for the data in our service as well. I mean, we understand this is critical to your business, and we treat it that way. So what else do we do? We have a bunch of algorithm and framework support. So as I mentioned, we have a set of built-in algorithms, and there's actually a session later today where I'll go into the specifics of the algorithms that we provide and some of the use cases that you can use it for. But we also provide the most popular deep learning frameworks. So if you're not just interested in traditional machine learning like linear regression or gradient boosted trees or some of the more traditional algorithms, you're interested in implementing your own through the deep learning frameworks, we also support those. And we support those in a very similar fashion as the algorithms that we provide. Or if you're a real expert and you have expertise on your staff, you have data scientists that feel like they are pushing the state of the art. And we have customers like that. We have customers like GE who spoke this morning that they have the top experts in their field. And what they want is for us to get out of the way and to actually provide an infrastructure that they can use to implement their algorithms. And in order to support those, we also support custom algorithms through Docker. And the advantage of having this through one platform is you essentially have a single experience that you can use, and you can iteratively go from, I'm going to try out some of the built-in algorithms to see if they work. And if they work, great. If they meet my business objectives, great. If not, then let me try and a further level of customization. And I don't need to change a whole lot in the pipeline. I don't need to change a whole lot in the overall process of going from data to a production-hosted model. The only thing that I really need to change as a customer is the underlying algorithm that's called within this step. So the goal for SageMaker is speed in all these phases. So if we're trying to address that 6 to 18 month time and we're trying to bring it down to days to weeks, we have to speed everything up. And we speed up training by making it easy to, you spend no time implementing the algorithms. If you use the built-in algorithms, you spend no time integrating in the frameworks. If you're using in the most common deep learning frameworks, whether it's TensorFlow, MXNet, Chain, or PyTorch, you end up spending no time on that, which means that your training is fast. Not only that, but we support single machine and distributed, and we even have some customers that are using up to 100 instances. And in fact, they're using up to 100 instances with, I'm trying to think of the number, it's something like 64 cores each. So they're running a distributed training algorithm with 6,400 cores, and it runs for 3 to 4 hours. So it scales. It scales. And this is not a simple thing to do, to scale algorithms to 6,400 cores. But we did this in SageMaker, and we want you to not reinvent this. It doesn't make sense for anyone to do this over and over again. If we've done it once, it's not something that you come up with novel solutions for, and everyone has a different solution. The second thing that we have speeded up is inference speed. So the infrastructure that we use for inferencing has very low latency. It's typically on the order of 20-ish milliseconds that gets added by the infrastructure itself, which means that you end up having very, very fast inferences, and you can scale it up. In the same way that you can scale out your training, you can also scale out your inferences. You can have 1, you can have 50 instances, and the amount of traffic that those 50 instances would be able to take is much, much, I mean, you can take huge traffic, particularly for the linear type models. And the advantage is you don't even need to decide that up front. What you can say is, well, I think that this is going to be something like 2 or 3 instances at minimum, and it goes up to 50 instances at the maximum. I want to make sure that we don't end up being subject to code bugs that result in us scaling out indefinitely and ending up with a lot of costs. So you can set the floor and the ceiling as well, and it'll automatically scale to take your level of traffic. Essentially, all you have to do is you have to say, this is the amount of throughput I expect from a single instance, and it'll scale out. And the idea there is that we remove the undifferentiated heavy lifting here. I mean, all of this stuff that I've talked about here is the same regardless of what your industry is in. Which means that what we really want you to do is we want you to be able to focus on your customer, your industry, the things that are specific to your business, as opposed to the generic things that are solved over and over again in computer science undergrad schools all over the country. It doesn't make sense for that to be a business focus. And of course, in order to make machine learning work, the thing you need to do is iterate, iterate, iterate. That's the way to success in machine learning. So another thing that we've done in order to make this iteration process faster is we've introduced what we call local mode. And in local mode, you're able to run essentially the same kinds of things that you could in the cloud on a local instance. And it could be your the local instance that's hosted by Amazon SageMaker, the notebooks that are hosted by Amazon SageMaker, or it could even be your laptop. So essentially what you're able to do is you're able to pull down the container that we use for training and inference. You're pulling down that container, and you're performing all of those operations locally, which means that you can take a small data set, you can iterate on that small data set, and then when you're satisfied with the way the performance is, you can then send that same workload, essentially using the same semantics, to the cloud, and then you can perform that same training on a larger set of data with a much larger set of instances in a distributed fashion. So essentially, it's not even Go distributed with 1 line of code. It's Go distributed with editing 1 line of code, where instead of saying, you're using the SageMaker.local instance, you say, I'm using 20p3.2x large. And essentially, now you have 20 GPUs at your disposal. I talked a little bit about automatic model tuning. Essentially, the kinds of things that you can do with automatic model tuning is you can tune things like the number of layers, the number of epochs, the learning rate, and so on. These are all parameters that would have an effect on both the quality as well as the cost of machine learning. And essentially, by optimizing them, you're able to optimize on a specific goal that's important to your business. One of the novel things that we did in this area is we made this automatic model tuning work across all of the algorithms. So it's not just our algorithms that it works for. It's not just TensorFlow or just MXNet. It actually works across everything, including the custom algorithms that you bring. So if you have a custom algorithm that you've developed and you package it up in a Docker container and you're emitting the variable that you want to optimize on into the logs, you can optimize on it. We'll perform Bayesian optimization on that objective metric, even though we don't know exactly what's in the black box that you have. So essentially, we've come up with a way that we can do black box automatic model tuning, which is pretty cool. So essentially what we do is we start this, you essentially kick off this hyperparameter tuning job or automatic model tuning job. That kicks off a bunch of training jobs. And you have control over the number of simultaneous training jobs. So you can say, well, I want to use 100 training jobs in order to optimize it, and I want 10 to execute at a time. Because the second 10 will learn from the first 10, the third will learn from the second and the first, and so on. So you have control over all of the parameters that you would use for automatic model tuning. And you define the objective metrics that are critical to your business, and this could be something like false positive rate. How often am I wrong on one of these things? Or you could say it's some combination of false positive and false negative, and use that as your objective metric for automatic model tuning. And then you go ahead and kick off the tuning job, and essentially it takes care of it. It iterates through the whole thing. It takes time in order to spin off the jobs, but you don't have to babysit it. It's not something where a data scientist would have to sit there drinking coffee and watching the screen as it goes through. It's essentially taken care of automatically, which means that the data scientist on your staff is freed up to do something that's much more important. In other words, the things at the beginning, identifying the business problems, finding the right data set, optimizing the feature set in order to achieve good results. So skipping through this a little bit. So we've actually had a fair amount of customer success with SageMaker. GE talked this morning. We've had a few other customers, including CookPad, who's doing recipe recommendations in Japan. Grammarly, I know, is pretty popular. They do grammar checking, and Grammarly is a customer that was very happy that we supported multiple frameworks because they use multiple frameworks in their processes. Tinder is another example of a customer that's very happy using SageMaker. This ability to speed up machine learning processes is something that you can use regardless of whether you're a small company with a small set of problems all the way to companies like Tinder and GE Healthcare that have very large data sets and pretty complicated machine learning problem and expertise. Intuit, as I mentioned earlier, was a launch customer of ours. They've been really happy about being able to accelerate their machine learning processes, and they started out with a pretty interesting use case, which is near real-time fraud detection using SageMaker. So as you might imagine, with a customer that has something like 40% of the GDP going through them in tax returns, something like that. It was a substantial percentage of GDP that flows through Intuit's processes. They have a fraud problem, and they need to solve these fraud problems really quickly. And the way they do these things is they have a set of processes that is upstream in order to collect the data. They use Kafka as part of their data collection pipeline. They process it into a feature store using Apache Spark and Amazon EMR. And this feature store is essentially what they use as the basis for developing their fraud or not models. They train the model in SageMaker. They host it in SageMaker, and then they consume it using their application. So essentially, they've gone from we're collecting this data that is indicative of whether a transaction is fraud or not, all the way through to we can now predict it in real time, and we can accept it or reject it in near real time, which is essential to their business. So what are the key advantages of SageMaker that allows them to be able to do that? First of all, it's zero setup for this exploratory analysis. They don't spend a whole lot of time on doing things like setting up the notebook environment. I mean, everybody understands that you need some sort of environment in which to view the data, process the data, and so on. Most people use things like Jupyter and Anaconda in order to do that. In order to make that easier, we have a hosted environment, a managed service that provides a Jupyter notebook with the most common libraries installed. It includes things like Anaconda, things like Docker, MXNet, TensorFlow in order to do local deep learning types of things. And it also does things like add a machine learning or a storage volume so that you have local scratch storage to use, connects to your VPC so that it keeps your data private. It encrypts the EBS, the attached EBS volume so that the data is encrypted at rest as well. And essentially, you have secure access to all of the services that host your data within AWS. We think of it as just add data, because not only that, we also have a set of examples that you can select from to solve very common machine learning problems. So you can get your feet wet using these templates and then connecting them to your data sources to see how machine learning will work in your situation. The second thing we provide is we provide a set of algorithms that you can use to get started with. And that's everything from things like matrix factorization for recommendations. We have regression for a wide variety of problems, principal component analysis for dimensionality reduction, and so on, as well as the deep learning frameworks I mentioned, Apache Spark integration. And that Apache Spark integration is present both in Amazon EMR, but it's also an open source library that we provide so you can install it on your on-premises Spark clusters as well. And you can bring the algorithm. But all of these, the idea there is that you would be accelerating your machine learning process through a better set of algorithms and a better selection of algorithms. And then we provide machine learning or distributed machine learning with a great deal of flexibility. You can select from 1, 10, 100 instances, and it's essentially the same kind of process that you would follow. And then, there's one other thing that I want to mention here. We actually do something somewhat novel in that we have a set of model artifacts that get stored in your S3 bucket. And essentially what that means is you have control over not only the data that you provide in S3, but you also have control over the derivative artifacts of that data, which means that you can take that and you can do inferences on device. You can do inferences outside of this. You can embed it in your application. You don't have a dependency that if you train in SageMaker, that you actually have to do the inferences in SageMaker. You can take them out, and you can take them anywhere you want, which gives you a great deal of flexibility for how to use these artifacts. In addition, because they're data derivative, that means that you can manage the lifecycle of these artifacts in the same way that you do data. So if you have a 7-year retention period on data, you can have a 7-year retention period on these data-dependent artifacts as well. And by separating the data-dependent portion from the data-independent portion, we provide you with the flexibility to be able to have business processes around that. And of course, we support CPU and GPU in all of these things. We support hyperparameter tuning in all of these cases. And it provides you with this fully managed solution, fully managed and secure solution that you can use for all of your machine learning needs. Last but not least, I'll talk a little bit about the model deployment to Amazon SageMaker. I talked a bit about auto-scaling, but one of the other advantages that you have is that you can actually do A/B deployments on the model in SageMaker, which means that as you're incorporating them into your application, you can do things like I'm gonna test business logic against machine learning. And I won't switch over to machine learning until the machine learning algorithm is better than the business logic. Or you could do A/B testing of machine learning versus deep learning and say, I won't switch to deep learning until I feel confident of those results. But it gives you a great deal of flexibility to do these partial deployments where you're testing and iterating. And essentially, that's the key to machine learning. It's testing and iterating and trying to see what works. And this is one more way that SageMaker gives you the flexibility to do that in a very easy way. Essentially, all you have to do is specify the 2 models that you would need to deploy behind a single REST endpoint, as opposed to just the one. And regardless of the framework, regardless of the number of instances, it's a single API call. You're just changing parameters within the API call. If you want to change CPU to GPU, it's just changing the instance type. If you want to change 1 to 10 instances, it's changing a number. If you want to change MXNet to TensorFlow, there's a little more of an effort because you need to actually code the MXNet and TensorFlow. But from the SageMaker perspective, it's essentially changing the MXNet object to a TensorFlow object. And the rest of it is very uniform. Let's see. The last thing I would mention there is that we also provide an open source Python SDK that is on top of the AWS Python SDK that provides an easier experience for machine learning practitioners. So we wanted to go a step further since machine learning practitioners don't necessarily have as much AWS experience. We got the feedback from early beta customers that they wanted a more Pythonic experience. So we developed a specific Python SDK in addition to the existing AWS SDK. Last but not least, it keeps getting better. So these are some of the recent launches. Since reInvent, we've launched tens of features. So we're actually keeping up a really quick pace of iterating. The 2 deep learning frameworks that we added, we added Chainer and PyTorch. I believe it's even in the last 3 months. We added HIPAA compliance somewhere in late May, June, something like that. Very recently, last month, we added batch transformation. So not only can you do real-time inferences, but you can also do these inferences in batch, which has the effect of reducing your cost for batch-oriented workflows. We're also doing region expansion. So for any organization that is in multiple geographies, we're now in 8 AWS regions, I believe is the number. And we're rapidly expanding to encompass all of the regions as quickly as we can. So we continue to iterate on it. The one other thing I'd like to add to this is that all of these things are driven by customer feedback. So we believe that you guys know best about what you need in this platform in order to make it yours. And we want to make sure that we're providing what you need in order to make it better. A lot of the security features were driven by Intuit and GE Healthcare giving us feedback that said, hey, you guys have to do this. We know you know what HIPAA needs. We know you know what PCI needs. But for our organization, because we're putting sensitive data in there, we need these things. And we took that feedback, we implemented them, we continue to implement things that customers ask for. And I feel like this is a wonderful way. This is largely a customer-driven platform is the way that I feel about it, and that's how our roadmap is designed. So let me take just a minute to kind of walk through what an end-to-end architecture looks like, and then hopefully we'll have a little bit of time for questions. So one of the applications that we've developed on SageMaker is style transfer. And this is the kind of thing, if you've seen examples of the machine learning algorithms that turn things into Van Gogh-looking paintings and so on. So you can take a picture of yourself and see what it would look like if Van Gogh painted a portrait of you. So as you go through, you can use things like code commit and code pipeline elsewhere in AWS in order to incorporate your overall development processes. You push the container of the things you develop into Amazon ECR and use that as the input for a training algorithm. And then that works off of the data set in order to provide a model that can be deployed to a SageMaker endpoint. The SageMaker endpoint you would front with something like AWS Lambda, so that you have a serverless environment with API gateway in front of it. And the kind of experience that you would be able to provide with that is a user submits a picture, and then they get the style transferred picture out of it. So last but not least, SageMaker is not an island. It's actually one of the many services that you would need in order to have an end-to-end machine learning platform. It's everything from storage in S3 to the compute provided by EC2 to all of the security infrastructure, whether it's identity and access management, VPC, the key management system, and so on, as well as the data analytics. And all of these end up in a broad, easy-to-use machine learning platform with the most customers. So thank you all. Please be sure to submit feedback. I would love to take questions at this point.